All right. Good morning, good afternoon, and good evening. Welcome to today's webinar on cybersecurity incident response plan development. This is the sixth webinar in our 10-part series on cybersecurity and digitalization with a focus on supply chain cybersecurity in the energy sector. I am Scott Morgan, Principal Consultant with Enernex, and I will help moderate today's webinar. So thank you all for joining us today. Please note, as you probably heard the little announcement, this webinar is being recorded and all the participants have been muted. The recording of the webinar will be made available afterwards, along with a PDF of the presentation slides. We'll be taking questions via the Q&A window, and we'll have time for questions after the presentation. So if you have any questions during the presentation, please type them into that Q&A window. You should see a button to open that at the bottom of the Zoom interface. Note, these questions are only shared with presenters and hosts. And finally, if we don't get to your question during the webinar, we will try to follow up with you afterwards and provide an answer. Today's event is organized through the U.S. Energy Association's Advancing Modern Power Through Utility Partnerships, AMP-UP program. The AMP-UP program is funded by the United States Agency for International Development, USAID. And as I mentioned a moment ago, today's webinar is part of a 10-part series. The overarching goal of this series is to discuss cybersecurity challenges associated with expanding supply chain necessary to face multiple transformations in the energy sector, including integration of renewables, deployment of grid edge technologies, integration of regional markets, etc. In today's webinar, we'll hear from Michael Martin at Chelan County Public Utility District and Tony Assam from the Ghana Grid Company, GridCo. Michael is a control systems engineer at Chelan, where he served as his organization's NERC CIP 008. That's the Incident Reporting and Response Planning Standard. He's that standard owner with responsibility for Chelan's CIP Cybersecurity Incident Response Plan from 2015 to 2023. As a seasoned information security professional with over 25 years of experience, he specializes in securing and protecting the energy utility sector and industrial control systems. Michael honed his cybersecurity skills in the healthcare and technology sectors, where he led initiatives to enhance data security and compliance for patient health records and intellectual property. Tony Assam is the head of IT at GridCo, with responsibility for IT strategy, systems deployment, and operations, with additional responsibility for operational technology systems. He is an information and communication technology professional with several years' experience in software development, IT product development, cybersecurity, and IT infrastructure. He also has expertise in e-banking technology and wireless microwave and fiber optic technology. So before I turn it over to them, just a quick reminder to the audience, please enter any questions during the presentation via the Q&A window. And if we don't answer them during the presentation, we'll try to reach out to you afterwards. So with that, let me turn it over to Michael. If you would please take it away.
Right. Well, good morning. I just want to make sure you can hear me first of all.
Yeah, perfect.
Okay, great. Okay. Well, thank you for joining us in this webinar. As Scott mentioned, I'm from the Chelan County Public Utility District, which is a county government utility created by a vote of the people here in the county. This public power utility owns and manages 3 hydroelectric dams in the Northwest United States. These facilities and a relatively low population enable us to sell surplus electricity to neighboring utilities in higher population areas like Seattle. Our utility also provides transmission and distribution services with more than 3,000 kilometers of distribution lines. The perspective I'm sharing today is from working in operational technology for the past 10 years at this utility. So my focus will be on that. So today my presentation is focusing on the respond function of the NIST cybersecurity framework, which involves developing activities to take action regarding a potential cybersecurity event to minimize its impact. These typical activities include incident response plans, drills, and communication during an event. About 9 years ago, I began managing our existing operational technology incident response plan. Since my organization is regulated by US NERC Critical Infrastructure Protection, or CIP regulations. At that time, NERC had introduced some major changes, and so I reviewed many NIST and Department of Homeland Security publications, including the two listed here, the Computer Security Incident Handling Guide and Developing an Industrial Control Systems Cybersecurity Incident Response Capability. I know those are a mouthful. Anyway, after reviewing those, I decided to follow the NIST model and then went on to significantly revise our incident response plan. The documents I just mentioned provided useful information, but to be candid, it was a lot of material to read and to integrate. So hopefully I'll be able to save you some of that pain by the things we discussed today. As illustrated here, the NIST model begins with preparation. An important step in preparation is to identify critical assets. You'll hear different methods of doing this from Tony. I think you'll get good perspectives later. But like all US power utilities, Chelan applies industry standard classification criteria from the NERC critical infrastructure protection to identify and classify critical cyber assets and their supporting systems with ratings of either high, medium, low, or no impact to the greater interconnected power grid. Based on the impact rating, these systems are then protected by appropriate physical and cybersecurity controls to mitigate their associated risks. In addition, Chelan uses business impact risk assessment to identify additional mitigations for these systems, such as insurance, support agreements, spare inventory, and preventive maintenance. While this photo that I'm showing doesn't show cyber assets, these burned transmission lines are a real threat in our area, and they also illustrate the principle of risk mitigation. After experiencing several serious wildfires, we took the action of where fire risk is high in our area, in specific areas, poles are now either painted with fire retardant paint or being replaced with steel poles. Although not a malicious event or suspicious act, fires and rodents have also damaged the fiber circuits used by our SCADA systems, connecting our hydroelectric projects. To address these risks, for important locations, we have established secondary circuits using either a diverse fiber path or a microwave link. When developing your incident response plan, I'd suggest not doing what I did and following the steps outlined in the more recent and also more concise Public Power Cyber Incident Response Playbook, which is based on work supported by the US Department of Energy. It's a lot more concise and is a good way to jumpstart your plan. 2 years ago, our IT department successfully used this as a guide in developing their incident response plan. And this guide can help you quickly develop your plan, and it's flexible for organizations of various sizes. You'll find links to this and other helpful documents on the resources slide at the end of this presentation. My advice is to develop a plan soon if you don't already have one, and then improve it over time. Whoops, jumped too far ahead. I'm a strong believer in the crawl, walk, run approach, and I think you'll find it helpful in developing a good incident response plan. The goal of an incident response plan is to establish a written systematic approach. Let's review some of the key elements of a plan. First, roles and responsibilities. These document all the participants involved in the response and who does what. Second is detection. I find NERC's definition of a cybersecurity event helpful. An abbreviated version of this is a malicious act or suspicious event that disrupts or attempts to disrupt the operation of a utility cyber system. To detect an incident, it's important to train your system operators and system administrators what to look for. The NERC Cyber Intrusion Guide for System Operators, as well as the NIST Guide to Industrial Control System Securities, documents list possible incident indicators that are specific to each of these roles. You also find them referenced at the end of this presentation. It's also important to establish processes to report suspicious activities and to analyze potential incidents and to preserve evidence. Our employees have found that a decision tree or a flow chart is helpful to know when to actually activate the incident response plan. And it basically applies the same NERC definition of what an incident is. But it's a good reminder, and a lot of our employees will hang this in their offices just so that way as they review things, they can reference it. Okay, containment consists of actions to prevent further damage. My suggestion for your incident response plan is to briefly list common incident types, such as malware, ransomware, or account misuse, and their potential containment actions, since these are often overlooked during the frenzy of an incident. An excellent playbook for ransomware is the US Cybersecurity and Infrastructure Security Agency's Stop Ransomware Guide, which is also on the resource slide at the end of this presentation. Consider referencing detailed playbooks like this in your plan. And for a lot of the scenarios, I've actually gone out and looked for different playbooks and then added them as references in our plan as well. The next step is eradication, which is simply removing the threat from your environment. Recovery involves the steps required to restore your system to full operation. When possible, keep spare hardware for important HMIs, computers, PLCs, RTUs, and switches in case of supply chain delays. For example, some of the network switches we use have about a 180-day lead time. And so if we needed to get them in a hurry, anyway, things wouldn't work out so well for us. So we keep spares for things like that. Although not typically part of a tabletop exercise, I recommend also conducting actual practice recoveries of different system types, like HMIs, SCADA servers, firewalls, network switches, and RTUs, to ensure your recovery processes work. As we've done that, we've found inconsistencies and incorrect documentation, or things may have changed. And so it's a great way to make sure everything's still functional and have a plan that you can apply and follow rapidly in a response. Communication plans are often overlooked. Document your preferred communication method, such as cell phones, Slack, Teams, WhatsApp, or Zoom, and backup options in case your preferred method's not available. In some of our exercises, we've actually disabled phones to force us to use other methods. Determine how communication will also occur between technical response teams, different departments such as system operations and physical security, and external groups like law enforcement, neighboring utilities, and the public. Once you have the key elements in your plan, it's important to test it. Even the best plan can't anticipate all the obstacles that will be faced, and practice exercises provide a safe place to work out these issues. Once a year seems to be a good frequency for incident response exercises. Before the exercise, have participants review the plan, especially their roles and responsibilities, as well as key sections where they participate. For example, security officers and public communications personnel can reference their particular sections of the plan without having to digest the whole plan itself. In developing exercise scenarios, consider using events in the news. One example is the SolarWinds code compromise that was discovered in 2020. We've used this scenario a couple times in different fictitious Trojan malware that in either SCADA software or our backup software. Ransomware also appears frequently in the news. You may also just use your creativity and develop an insider threat scenario. As we've conducted exercises for the first several years, I planned them out, and I'll admit my creativity started waning. So then we decided to share this responsibility and rotate it among different people in our group. This last year, we actually had one person create enough to create a test virus that actually gave people could find test injects and evidence in different places to help us play along and make it a much more realistic plan. To improve the plan, using the plan during the exercise is vital, and I can't emphasize that enough. If people aren't looking at it, it won't improve. So have participants write their name and comments on the plan to capture deviations and improvements. Exercises offer training, pardon me. Exercises offer training opportunities for responders and provide insights into other teams and the capabilities they offer. After testing your plan, hold a lessons learned meeting to gather feedback to improve your plan and response process. Your utility will be better prepared for future incidents. These are examples of questions you may ask to solicit participation. Recording the responses and then acting on them is the best way to improve your plan and to enhance both your organization's security and response posture. One of the questions here that I'll definitely emphasize is, could this incident have been prevented? Lessons learned feedback is key. So for example, some of the feedback I received was the plan was too long. Responders wanted a shorter plan, so I moved supplemental information as attachments to the end of the plan. Some wanted a decision tree flowchart with a checklist to ensure critical steps weren't missed. I also received suggestions to reorder the plan to provide a more logical flow. Our communication plan also didn't reflect reality. Initially in our testing, we all met in a conference room surrounding a table and walked through the scenario, which isn't really how people act in an incident response. In later exercises, like the nationwide GridX exercise, we involved more departments and participants worked at their desks to simulate a real event. This identified many communication challenges and also helped us find out what methods work best. Some improvements that resulted from our incident response lessons learned meetings included architectural improvements, such as a new file server design to address malware events, additional security cameras in new areas, penetration tests of important networks, improved event notifications such as after-hours login or workstation unlock alerts for people who typically only work during business hours. After testing a USB keylogger, we created alerts for USB connection changes. We also acquired new tools such as a network monitoring solution that stores packet data that assists both with operational troubleshooting and forensic analysis. Here are a few suggestions on how to effectively use your plan. First of all, print your response plans as well as contact lists to ensure it's accessible during an incident. Put the revision date and a header or footer on each page of the plan so responders can make sure they're using the current version and the same version of the plan. Document delegates or backups for each role so the incident response isn't slowed when someone's not available. Also empower people to make decisions to facilitate efficient responses, such as, can a manager make a decision instead of a higher level director? Also include incident response resources in your plan, such as a contracted incident response service, government resources, or neighboring utilities that might be needed. This concludes my portion of the webinar. These are the references that I mentioned, and I think you'll find that they provide more detail that can help you in your incident response plans and incident handling. So I wish you the best in this. Thank you.
All right. Thank you very much, Michael. Let's switch over to you, Tony. If you would share your screen, please. And Michael, would you please stop sharing your screen? Did we lose Tony? Thank you very much. Go ahead. If you're speaking, we can't hear you at the moment. It does look like you are unmuted though. We do see your screen.
Hi, Scott, are you ready for me?
Yes, please take it away.
Thank you so much, and good day, everyone. So I am Tony Hassan, currently head of IT, and also have additional responsibility for OT and CISO. OT is operational technology. Okay, so I will be speaking on the incident response through supply chain preparedness. And I think that I will also go ahead to share what we have done by way of how we have. I'll share a case study on how we have managed our part of incident readiness. Okay, so I'll do a quick run through an intro of our background. I'll look at why OT security is critical. I'll look at our OT incident management and also using a SCADA upgrade as a case study. So for those of you who do not know Ghana, where Ghana sits, it's on the western part of Africa. And Gridco, we are a power transmission company. A few years back, we used to be one company doing generation and transmission of power. But then because of the growth in the industry, it became apparent that government alone could not function in that space. And so create room to welcome private players. We call them IPPs, independent power producers. We currently have 10 of them in the industry, and then they are generating a total together about 5,231 megawatts. In terms of our circuit, we have about almost 6,500 kilometers of transmission lines, driving peak demands as of December 2023 of 3,618 megawatts. We have 32 bulk customers drawing from this infrastructure. And a bit of also continuing on the background, we in Gridco operate both the IT and OT environment. We have been careful to separate them for good reason. But we do not just serve the country Ghana. Where we sit, we are surrounded by Cote d'Ivoire in the west, Burkina Faso in the north, Togo on the east, and then Benin further east. Now, we are interconnected on the grid and we transmit power both intra-country and inter-country. So you would agree with me that impact of outages are potentially dire. We're talking about financial losses into millions of US dollars in a daily basis. We talk about negative impact on GDP. And this, in my country, for example, 80% of our GDP also hangs on electricity. It also has cybersecurity implications. You can imagine when there's an election in our current stable environment, and then at the point of collating results, power goes off, all sorts of suspicions and things, and many of the things that are likely to happen. So it is also important to understand the basis for driving cybersecurity within OT infrastructure, and also why you should be deploying an incident response plan. First of all, the threat actors can introduce compromised components into a system, either intentionally by design or unintentionally, at any point in the system's life cycle. It's an unpleasant thing to have, but it is a real and present danger. Also, attackers set sights on industrial control system. I'm talking about operational technology, knowing that these are what controls machine-to-machine communication, especially in the power sector. We also need to understand the supplier's maturity and security processes and be sure that they comply with your own structures. If they do not, it's already a vulnerability. So it's important to make sure that that box is ticked. And for a broader perspective, you want to see how these things play out both in IT and IT by way of information technology and also in operational technology. So in terms of focus area, in IT, you would look at information management, your digital technologies, what would work and what should not, and also internet and connectivity generally. In OT, it's slightly different. You're looking at direct control of devices and processes. You are looking at very important element of reliability and continuity of operations. A blip is always a problem. You're looking at system response times. Any high latencies could prove a dire consequence for your establishment. Now, in terms of devices, IT, we have commonly connected devices like PCs, mobile devices, running operation systems and applications. And typically, refresh cycle is about 3 to 5 years, where almost every 3 years, you know that there are new versions of either operating systems, other hardware, or something you can always procure to replace. It is not like that within the operational technology environment. In that space, you use customized operation system devices running OEM applications. They are running proprietary and sometimes embedded devices and custom production systems. Also, refresh cycles could be as long as 20 years. We have devices that are over 12 years in our system, and they are functioning well. It is not something you want to go and touch. Our SCADA currently has been running for 14 years before this upgrade. So you do not have to touch an operating system if it's not broken. That is what we have done, and especially works like that within the OT environment. And usually you have many legacy devices in your system. Sometimes you know them, sometimes you don't, because some of these devices are actually embedded, making it a bit opaque for you to identify them easily. Also, in terms of threat identification, when you talk about IT, there's extensive databases of devices with vulnerability identification. It's very easy, you can find them. And because of this, you have lower zero-day vulnerabilities. This is not the case with operational technology. Here, the challenges in identifying domain-specific threats and threats exist, and they're higher exposure to zero-day vulnerabilities, because if they are embedded devices, you do not know specifically what's wired in them. In terms of remediation, in case of events, it is simple and more available within the IT space. You have lower operational risk because you have replacement systems all over the world, and most of them are interoperable. So once you plug one, you can stick into the other, and you are likely to work. And it is not the same with the operational technology. Here, the remediation is complex. Threat remediation is complex. You need to know your environment. You need to narrow to where these devices are. I mentioned earlier, some of these devices are legacy, and so you don't have readily available spares and all that, but they are there. And these are things you need to take note of. Also, you have high operational risk. Incorrect actions can halt production, and some of these things have very fatal results if not properly handled. So it's important that we get this picture in how we are planning your incident management. So in GridCo, we have adopted the NIST framework for operational technology security, and this is the NIST 882 revision 3. It has almost everything you need. I must warn that this is only a guideline. It is not everything in that will work in your environment. So that means that whilst adopting to this guideline, you need to know your environment. You need to know your environment well, so you know exactly how you can apply this framework into your space. And so the other thing is that this framework proposes a 4-step approach I think Michael spoke about them earlier, so I won't belabor that point. But basically, preparation and prevention, detection and analysis, containment, eradication and recovery, and post-incident activity that includes testing of your plants. So in preparing to, in your planning, preparation is key. And I must say it's the biggest and most difficult of things you do. I guess it flows with the saying that says that if you fail to plan, you plan to fail. And so it is important that you develop capacity to be able to calculate your business impacts and use or apply your existing risk analysis to, and also identify all supporting systems and assets. And then when you have done that, you have to triage the assets, as in prioritize them into ways that will make your recovery a lot more efficient. Now, in Gradeco, for example, we have adopted a KPI that says that we must be able to recover 80% of all our operations within 48 hours of a total outage. And so based on this, we have gone ahead to design an incident response plan just so we are able to meet this one. And I can say that today, in terms of applicability, we are about 95% certainty. And so, and because it's a continuous process, continuous improvement process, we can only grow and not diminish. In terms of specific applications, here, what we have done is to bring together the team that would help with these calculations. Now, typically, you look at when you want to calculate your risks generally are the probability of an occurrence multiplied by the actual impact. And so we use our finance teams, our procurement teams, our technical engineering teams to determine these elements. So for example, in terms of probability, we look at specific provisions in vendor documentations. We look at we use our own experience of running the systems. And so we know that this has run for 10 years, it's gone out only once or maybe never. We look at other capability in terms of the skill set of our engineers, and we are able to come up with these raw probabilities. And then we calculate our impact. And by impact, it's about when you have an issue, what size of your operations is this affecting? So we know that. So when we put them together, we are able to determine our risk. We don't stop there. We proceed to check what our treatment costs are. And then also after doing the treatments, we also check to see what the treatment probability, we call them. So that is a residual probability of occurrence even after actually going ahead with your treatment activities. And then after that, you compare your current risk, that is post-treatment risk, with your target. And if there's a gap, you always go back and rerun that process all over again. So basically, this is how we have crafted and calculated risks and how we are mitigating them. And in fact, it has served us well, because some of the things that we had not done because we had not calculated them was able to put figures and numbers to potential risks. And so it's helped the business to be able to position itself properly in terms of how to handle systems. The second step is about detection and analysis. And here, what we do is to take steps to put safeguards in place. And so we ensure to deploy relevant systems. And then because this also has a huge supply chain impact, you realize that vendors, we make sure our vendors meet our own criteria to qualify the vendor to be able to partake in any tendering process that we will put out there. We also implement security by design. That means that right from the scratch conception, when you intend to install any systems or deploy any new technology, we start by design. What do you want by way of security? How are you safeguarding your installations, the new ones, to make sure that they will comply with your security targets? We do all that. And when we have gone through the tender process, we actually inspect the tenderers' security compliance notices. There are documents that we have demanded and would add, we review and validate all of them to make sure that they actually comply. And in fact, in cases where some of these things have been blunt and not covered, we would make sure that you, the vendor, would not be exempt or would not be, as it were, indemnified from any effect should anything happen. And whilst doing the process, one of the things we have done is to actually undertake a factory acceptance test. So before you supply what we are procuring or what we have procured, we make sure you have assembled it in your factory. We have come and we have tested it. And we don't test only functionality, we test the security provisions as well to make sure that it's watertight. And then we can bring it. And when we have installed it, and we also do what we call the site acceptance test, SAT. In this test, we test functionality, make sure everything else is okay. We make sure that we have tested from cybersecurity point of view, validated firewall rules, validated all other hardening that must be done in the system to make sure that they are secure. And then also on people, you know that typically people are the weakest link to any security in any setup. So we make sure that for people, cybersecurity awareness programs and simulations go on all year round to make sure that our people are not paranoid, but are aware. They have developed a culture of awareness so they are able to help us to respond speedily to any events. And then the third step is containment, eradication, and recovery. Here, it's about how do you respond in case of an incident. And of course, we have had incidents. We have not as in service impacting incidents, but sometimes something comes out. And before we fine-tuned our processes, you realize that we were shooting off a lot of false positives, but we have improved. And we share how we were able to do that. But basically, we need to be able to trigger a response process quickly. And also, once it is triggered, immediately we start looking at what could possibly go wrong with the troubleshooting, and all that will go on. Incident management starts. And then when we have any positive sign, any positive information, then we begin communication route. And of course, we'll first inform management. And we have three major entities that we must, as by way of regulations, by way of regulatory provisions, report to. This includes our Cybersecurity Authority, our National Communication Authority, and our Ministry of Energy. So we make sure these people are informed, or not just informed, but depending on the criticality of the event, we would have to either inform them on an hourly basis or 6-hour basis, but we have a key that we use to decide how we're tracking this. And then post-incident activity. Here, what you do is that I have mentioned that we do simulations. So occasionally you will get a seemingly threatening email, and if you are not aware, you can click on something. I mean, we use those to simulate potential causes and potential issues. And once we see them, we treat them as if they are real issues from our side. In fact, the users themselves who may fall prey to this do not know it's a simulation. And so we make it as real as possible. And once you have done that, you document all your simulations, and our compliance teams will ensure that every lessons learned is recorded. And all simulations in OT, we of course also carry out some simulations in OT. Results are recorded and compared with expected outcomes. And then our plan is reviewed yearly. Of course, we test this plan. Simulation is one of the ways we test them. It's important. I think Michael mentioned earlier, it's important that you test them. You will not know it works or not until you have tested them. So it is not just about creating the process. It's also about making sure they work. When we started this whole thing, a typical incident will take us about 24 hours to respond to. Now, in 2022, we went through a USAID-sponsored business innovation project. And in that, we focused on cybersecurity and process improvement. And so we use Lean Six Sigma to refine our processes. to the extent that what ordinarily was taking us 24 hours, today we're able to do in 30 minutes. We're able to respond in 30 minutes simply because there were a few, maybe small, but they would consume a lot of time, and we've taken them out of the loop and used automation to fix them as much as possible. So we have improved our operations, and so today I'm happy to say that when we have a medium minor issue, we can handle it in minutes. If it's a major issue, we can stretch it. I mean, of course, we have a KPI of 80-48, and so we make sure that we work within those. But this whole thing, one of the key things, some of the key things we learned from them is that, listen, you must know your suppliers and third-party suppliers. You must know them, because if you do not know them, it is very difficult to engage them. Now, what we have done is to create a database of all our suppliers and what they supply, and we have categorized them into P1, P2, and P3. So we know who's supplying the most critical of our elements and all that. And it helps, so you know specifically how much time to calculate to be able to reach a supplier and their turnaround time of delivery. Also, we undertake periodic assessment of their cybersecurity compliance status. This is something that is tedious. I mean, in your lots of busy schedule, this is something you can miss, but at least it's important to assign the accountability to somebody to ensure that this is actually carried out. And then vendors would legally accept responsibility for their undeclared vulnerabilities. Now, if anything should happen, I mean, it's not everything that I can see. If there are embedded systems, you would not know, but the vendors would know. And so what we do is, as part of a contract that is signed with them, they accept responsibility for undeclared vulnerabilities. And they would be held liable in case anything happens from a vulnerability that otherwise has not been declared. We also take seriously our pre-tender cybersecurity assessment for specific activities. I think I mentioned that earlier. Now, a case study. I mentioned that in 2023, we set out to upgrade our entire SCADA systems. Now, this is a huge project at a huge cost. And so we were guided by our incident management planning. And so we made sure that we're procuring right. We make sure that we are deploying right, and we make sure that we are operating right. So in terms of the scope, it involved the complete upgrade of SCADA system, including also deploying a disaster recovery control center, which was not originally existing. This is part of the safeguard. We also ensured, as I mentioned earlier, security by design during our scoping and requirements gathering. We did our pre-qualification, cybersecurity pre-qualification of our tenderers. We took them through our process, made sure that all of them would comply with our cybersecurity provisions. And tenderers would accept undeclared responsibility for undeclared vulnerabilities. We went on factory floor, we went to Europe, we sat with them. We actually did configuration from first principles with them to make sure that all issues, we have tested every element. Those that were not ready, we outlined them as outstanding issues list, which we made sure was going to be fixed before installation on site. And after installation on site, we undertook our site acceptance testing before the project signed. And this includes our cybersecurity reviews and regression testing, firewall config and setup, our hardware and operating systems hardening. We made sure we have dual redundancy AD systems, and we tested them to make sure they work. And then we actually did a red team attack attempt as part of a simulation to see what is likely to go on. And I'm glad to say we have deployed a very solid system, which fits our purpose in accordance with our cybersecurity provisions. In conclusion, I would say that the energy sector, especially with OT, operational technology cybersecurity threats landscape, is rapidly evolving and expanding. Attacks are now many and varied, and they are more frequent. The power sector is one of the most targeted. Your guess is as good as mine what the reason is. The actors are increasingly getting and using sophisticated malware tools. And as I outlined earlier, interruptions, disruptions have extremely dire consequences. Supply chain has become one of the most challenging vulnerabilities to address. And this is partly because supply chain accountability are usually not defined, not well defined, and CISOs are not meant to. They have little or no control over their supply chain activities. But no matter how challenging, companies can start by identifying and mapping critical assets using a maturity framework like what we have in NIST to assess their maturing level and take steps to treat critical gaps. It is extremely important. Incident management and incident management response. Incident management response is as important as incident prevention. You can build any system the hard way, the hardest way you can. But if you have not built capability to respond to attacks, work done would be zero. It's important that you respond clearly and quickly, decisively within your own set KPIs that works for your environment. Thank you very much.
All right, thank you, Tony. I think that was really great. We had one question come in through the Q&A, which Michael responded to in text, but I'd like to put it to you as well, because I think you mentioned it, Tony. You said you had to fine-tune your detection capabilities to address false positives. I guess, can you talk a little bit about that and how you kind of update your incident response plan to address sort of what you're detecting?
Okay, so first, we use skills that we had when we took that course with the BIP program. Now, typically, when an issue happened, the first thing to do is, let me report it whilst I work on it. But actually, it's not the best of plan. You can't report without knowing what you are reporting or without understanding the scope of the issue. So in this process, one of the first things we did was to learn that you first have to size the problem. And in sizing the problem, you know, by the time you first get your first diagnosis, you know that it is either a false positive or not, you know, before you actually shoot off. So this is one way, by way of process and procedure. The second thing is that we have deployed two key systems. I am unable to mention them here, but we have deployed two key systems that are helping us. So instead of the many issues that will typically flood our gateways, we have seen that that has dropped tremendously. And so we have a higher probability of positive reports. And so that reduced our basically false positive drastically. I do not recall in the last couple of months if I have seen a false positive. Anything we have seen and we have dealt with. And this tool I'm talking about has AI capability to actually treat an incident when they see them. So they report to you only when the tool itself is not sure. And so you have to go and validate and verify to be sure that it is actually a true or false positive. So these three things we have done has helped us to tremendously reduce our false positive reports. Thank you.
That's great. Thank you, Tony. Michael, did you want to add anything there on sort of fine-tuning those detection capabilities? Maybe on mute.
Yes, we're on mute, and I have some additional people with me now. Sorry.
Hello, welcome.
Set up this way. So absolutely. as far as fine-tuning detection capabilities, we get lots of events. And so we have a SIM, or a security information and event monitoring system, that receives literally millions of events every day. And those obviously aren't all actionable. We have some systems that, when I put it in the comment there, but we have some HMIs that after their patch, when they reboot, they always come up and do the exact same firewall hit. And so on our patching schedule, we see all those come in. And so we just auto acknowledge those, so that way there aren't noise that distracts us. And so we use a lot of regular expressions to look for similar types of events. And so when there's something that's a known or a benign event that we're absolutely sure of, we configure auto acknowledgement rules to kind of weed out that noise. And so a key is just understanding your environment, and it's a learning process and very time consuming to say, this is normal, happens all the time, and to weed that out from what's unusual.
Okay, thanks. I think I'll put this to Michael first. But Tony, I think, laid out some of the really key differences between an IT system and an OT system. I'm curious if you sort of see the same differences, but more importantly, how do those differences then follow onto some of those containment and eradication capabilities? Do you have to tailor those capabilities to IT versus OT system, or is it a lot kind of carry over from one to the other?
Okay, so two things. First, it fits into your incident management plan. Once you know the difference, it should lead you into choosing the right expertise to lead the process of planning your incident management, to also procure the relevant tools. And in my case, the second part is that you need to actually separate your OTE and IT. You don't need to, it depends on your environment. You decide what you want, but we have realized that it is important to do that. Now, having done that, it only says that if I'm deploying a certain tool, then know that what you are going to deploy for IT would not be the same as what you deploy for OT. Now, the critical difference here is that some of your legacy elements, embedded systems within OT, are so legacy that they do not understand the signature of today's of elements in today's technologies. A common ping or a probe to a device can shatter it. So when you have an OT specialized tool, it takes into consideration all that. So it helps not for you to go and procure something that has worked beautifully in the IT environment to come and deploy in the OT environment and expect it to function the same optimal way. So once you have understood these basics, you know typically what to go for your OT. Thank you.
Michael, anything to add there? Or?
I agree with what Tony said. I'm an advocate for focusing specific resources in OT environments. In our environment, we are separated as far as IT and OT, and it allows us to give special focus and attention because the environments are, as Tony pointed out, are very different. Might not be popular by saying this, but I think OT is a little bit easier because it's more of a static environment. Anyway, we don't have internet-facing firewalls. We don't have to worry about email and a lot of the other different attack vectors because we have an air gap between us and IT and limit that only to critical information exchange, such as like schedules and accounting that flow back and forth. From a cybersecurity response plan, ours is different from IT's because due to NERC CIP requirements, the OT side is required to have additional sections and components specifically for compliance that aren't required in an IT plan, for example.
So next question, I guess, Tony, start with you. I wanted to ask sort of how you manage those relationships with suppliers and vendors while planning that incident response? Are you trying to have those relationships in place with the vendors who supply components for critical systems? I think it also kind of flows into one of the slides Michael had. I think the flow chart, specifically one of them was a vendor alert. So, I expect that is a requirement, but I imagine that, some vendors are probably good and communicative and some might not be. So how do you manage them?
Okay, so Scott, typically our interface with suppliers is supply chain. Now, what we need to do is first look at how supply chain is engaging these suppliers. By laws of our country, you need to procure according to a certain format. Incidentally, that format does not include anything cybersecurity. So we have to work with our procurement to make sure that you have this in there. And we are engaging our suppliers on two fronts. One is a supply front by way of procurement, and the other is operational front. By way of procurement, I think I have enumerated the processes that we use, making sure that you have complied with our cybersecurity policy provisions. What we should be doing, and we have not done as much, is to getting them on at least once a year annual conference to share with them the new things in the industry from our point of view and what we expect of them. That has to be done. The other part is creating a database of all your suppliers and what they supply you. Be able to categorize them into by way of criticality. How critical are the elements they supply to you? And so that is at the procurement side. In terms of operation side, we have recently come up with a document which which encourages the suppliers to sign, or in fact, when they request, for example, remote access into our environment. Typically today, we have physically disconnected them. So if we have an issue and a vendor has to log in remotely to support, it comes by way of an application. It is vetted. As part of the vetting or as part of the application, you need to state how much time you need for the activity. And so we'll open you up for you to come in through a secure VPN over that period of time. And then all these things are documented to make sure that indeed you are not going beyond your scope. Now, in that document, one of the things you will find there is that if by your coming in and you're working in my environment, there is a fault, your organization will be liable. So it is not as draconian, but it is made for the vendor to understand that they have bounds when they are providing support for us. And so this engagement is all formalized to make sure that when vendors are supporting us, when they are procuring, we are procuring from them. We procure right and they support right, basically. I hope I have helped. Thank you.
No, I think that sounds phenomenal and really good on you for kind of pushing that on them and making sure that they hold to those standards. Michael,
yeah, this is Michael's colleague, Adam Gormley. I work in his same work team. So good morning, or whatever time of day it is where you're at. Yeah, I am the standard owner for what we call the supply chain risk management standard. They call it SIP 13. That standard addresses supply chain risk management and vulnerability kind of mitigation processes. Are we still live there?
Yeah, you're good.
Okay, sorry, our display changed. So that process essentially works a lot like what Tony described in terms of we have a standard contract that we have developed. And with every new vendor that is applying any kind of technology that we intend to use in our critical infrastructure environments, we lead with a negotiation attempt at telling them, hey, this product we're going to use is essential to us to maintain security with. We want to negotiate, and we engage them that way, and then we work through that process. At the culmination of that review with the contract, it has all the stipulations like Tony mentioned of communication of vulnerabilities in their products, things saying you guarantee you have no backdoors that you've implemented in the software that will let you compromise our system or anybody else without our knowing or without coordination, the remote access controls that he also described, and a number of other kind of end-of-life system protections and things like that to make sure support is maintained, patches are released on a pretty regular cadence after vulnerabilities are identified, and things of that nature. So it goes into a set of controls that are protecting our assets the best we can, at least through our supplier agreements. Once that process completes, we run that through a risk assessment, and then that risk assessment ultimately decides whether their willingness based on the negotiation to support our procurement from them meets our needs or not. And then we either proceed with the vendor or we reject the vendor, and we keep looking for other solutions that may exist that are a lot less risk. So that's kind of the general consent, how we approach our vendor risk assessment supply chain at the moment. I'll say it's wholly separately designed for the OT environment. The IT systems use different processes. This one is specific to OT. It's partly due to our regulatory requirements, but it's also, I would say, essential for people to invest the time for their critical systems in general.
Yeah. Okay. No, that sounds great. Thank you. So I want to sneak in one last question. So when kind of you're talking about that those requirements that you're putting on these vendors, I'm curious, does your incident response plan help drive what those requirements are, or do you end up having to sort of update your incident response plan based on the capabilities these vendors are able to deliver? Sort of which is first?
Well, they sort of interrelate in a lot of the risks that the supply chain management process cares about are things that are documented as potential attack vectors within the incident response plan. So they should pair in some way to say, okay, these are the risks we think we have, and then these really should be the things you talk to your vendor about to figure out what they're doing to help you mitigate these risks in addition to your own internal controls. So in a way, they should complement each other, although they are a different focus. The risk, instead of being like, how do I prevent malware, is how does the vendor prevent malware entered into their product, for example, like the SolarWinds example that Michael mentioned in his presentation, which I highly, highly recommend looking at. I used it a lot in my assessment for how we do our processes. That event is very informative and is worth reviewing.
Great, thank you. And Tony, I guess I'd like to give you final words.
Well, I think that thanks for the opportunity to present here. And as we have discussed, within the supply chain scope of things, it's important that CISOs get involved, regardless of organization, because that's where it all starts. And once that is done, you are sure to get a better hold on your supply chain requirements, and also involving your vendors in your environment. It's important because cybersecurity has become today's biggest weapon against any setup. And OT, industrial control systems in particular, are very difficult to recover from such incidents. So it's important that organizations focus on making sure we procure right. Once we procure right and we operate right, you are 90% safer than before. Thank you very much.
Thank you. So with that, I guess let me just close out that, we're here just a little past the top of the hour. So I want to say thank you again to Tony and Michael for sharing your expertise and experience, and to Michael's colleagues as well for joining us. So just a final reminder, the recording of today's webinar will be uploaded to USEA's YouTube channel, and a link will be added to the event page along with PDFs of the presentations. So next up, we'll have the 6th webinar in our series, which will be held in 2 weeks on March 21st. And we'll cover governance policies and procedures for third-party cybersecurity risk management. So I think something that Tony was already alluding to, the importance of. So our webinars will proceed every other week thereafter. So please be on the lookout for email announcements or visit usca.org/events. If you've missed previous webinars in the series, you can see them on USEA's YouTube channel. So thank you again for joining today. Hope to see you again at the next webinar in 2 weeks on March 21st. And hope everyone has a great rest of your day. Thank you very much.
Good rest of it.
Thank you.